425,000. Right off the bat, I want you to think about that number, because that isn't some corporate revenue projection or an overly ambitious production goal. No, that is the massive, yawning labor gap of new workers required in the U.S. construction industry alone by the year 2026, just to balance supply and demand. It's a staggering figure, right? And it establishes this incredibly pressing human reality that's fundamentally driving the sudden, unprecedented rise of machines in our daily operations.
So, welcome to today's Explainer. Today, we are going to completely decode the hard data behind this impending 2026 humanoid robot boom. We'll be taking a neutral, strictly data-driven look at the socioeconomic realities of this shift. We're stepping away from the science fiction tropes to examine the actual corporate math, the staggering technological leaps, and what this transition literally means for human workers like you and me.
Okay, let's dive into this. Here is a quick roadmap of where we're headed today. First, we'll look at the new economic imperative, then run the math behind the machines, explore intelligence on the factory floor, tackle the human impact, and finally, discuss adapting to our robotic future. All right, kicking things off with Section 1, the new economic imperative, and how industries are automating through a sluggish cycle. Look, faced with rising power costs and a continuously shrinking labor pool, building a smart factory, it's honestly no longer a high-tech luxury. It's an absolute necessity. I mean, a massive 86% of employers now view AI and collaborative robotics as their primary levers for business transformation. Automation is basically standing as the definitive hedge against an aging demographic and a rapidly dwindling supply of manual labor. It's adapt or fall behind. So what exactly is making this transition happen right this second? Let's move to Section 2, the math behind the machines. And this brilliantly illustrates the financial shift CFOs are staring at right now. And frankly, it is staggering. On one side, a single U.S. manufacturing worker costs around $156,000 annually. And that's when you load in base wages, benefits, overhead, payroll taxes, the whole shebang. On the flip side, the base hardware costs of a Unitree G1 humanoid robot is just $13,500. Wrap your head around that. A humanoid robot now costs less than 9% of an annual U.S. manufacturing salary. When you actually plug those numbers into a standard payback period analysis, the jaw-dropping ROI math becomes crystal clear. For a single shift replacement, the payback period is literally just 1.9 months, less than 8 weeks. And if that robot works a multi-shift operation, essentially replacing 2 full-time humans, that payback period drops to a single month. This pushes the 5-year ROI into the thousands of %. Automation is no longer some theoretical boardroom debate. It is just a basic spreadsheet decision at this point. Now, to be perfectly clear and totally fair, that $13,500 is just the sticker price. The true 5-year total cost of ownership actually ranges from $32,250 to roughly $39,600. Because, you have to include necessary hidden costs. Things like a $10,000 implementation fee, ongoing maintenance, infrastructure upgrades like Wi-Fi mesh networks, and of course, mandatory OSHA safety certifications. But honestly, even when you factor every bit of that in, the total 5-year cost remains incredibly low compared to paying for continuous human labor. And we know for a fact these aren't just pie-in-the-sky spreadsheet numbers, because we actually have the hard, on-the-factory-floor production data to back it up. Take the Figure 02 humanoid robot that was deployed at BMW's Spartanburg plant. That thing logged over 1,250 hours of runtime, loading parts across more than 30,000 vehicles with an astonishing 99% placement accuracy. The hardware is out there, right now, actively proving its value. But it isn't just the hardware getting cheaper and better, it's the software making them remarkably smarter. Which brings us to Section 3, intelligence on the factory floor and the rise of physical AI. Just look at the sheer velocity of change when it comes to software interest. In industrial applications, the interest in large language models, the same tech powering things like ChatGPT, saw a massive year-over-year jump. We're talking nearly doubling, from 16% in 2025 up to 35% in 2026. Manufacturers are sprinting toward these complex language-based tools. So what happens when you combine those advanced large language models with robotic hardware? You get what the industry is now calling physical AI. Basically, this is the integration of generative AI and world models directly into the machines. It completely transforms robots from simple tools executing blind, repetitive programming into highly adaptable conversational coworkers. We're talking about machines that can dynamically navigate spaces that were originally built exclusively for humans. And all of this leads us directly to the most critical and honestly, the most sensitive conversation. Section 4, the human impact, where we have to weigh job displacement against productivity. So the crucial point is captured perfectly in this pretty stark academic warning. By the year 2030, automation has the potential to eliminate approximately 800 million jobs globally, accounting for nearly 20% of the total global workforce. I mean, wow. The risk here is incredibly real, particularly for workers in low-skilled positions or those whose daily work revolves around easily programmable, routine tasks. However, to balance out that caution, we really have to zoom out and look at historical economic data. Because historically, the implementation of technology that boosts productivity actually reduces the amount of human labor required to produce a unit of output. For instance, between 1950 and 2015, advanced economies saw a substantial decline in average annual hours worked. Increased productivity often leads to higher average wages, significantly better living standards, and an overall increase in human leisure time. It's a trade-off we've navigated before. We can contextualize our current anxieties by looking back. Just as the 19th century Luddites feared being permanently replaced by steam engines and mechanical looms, 21st century workers fear AI and robotics. The short-term displacement is painful, and it is very real. But economically speaking, the cost savings and increased profits generated by automation are typically reinvested. And that reinvestment leads to long-term job creation and localized demand spillovers in areas entirely outside of those automated tasks. So, knowing this macro shift is virtually inevitable, how do we prepare? Let's move to our final section, adapting to our robotic future and the specific skills needed for the automated economy. Now, what's really interesting about this slide is how the future of work is essentially dividing into two very distinct paths. The jobs that are most resilient to automation, the so-called safe jobs, rely heavily on things machines still really struggle with. Think complex human judgment, deep creativity, and nuanced social intelligence. Meanwhile, this whole shift is actively generating exciting new emerging roles, driving massive demand for AI developers, data analysts, and robotics maintenance specialists. But here's the thing. Workers can't make this massive leap alone. Ensuring a smooth and fair transition requires a deeply collaborative effort. It means individuals committing to lifelong learning, for sure. But it also means employers and educational institutions stepping up to establish robust retraining programs. It requires governments building sturdy social safety nets for displaced workers. And really, society as a whole fundamentally integrating digital literacy into foundational education right from the start. All right, let's bring this all together. Section 6, Conclusion, looking ahead to 2030. The integration of robotics into our lives isn't some distant science fiction vision anymore. It is our present economic reality. But remember, the ultimate goal of this collaboration is not to replace human creativity, but to elevate and strengthen it. And I want to leave you with this provocative thought. Industry forecasts project that the cost of humanoid robots will drop another 68% by the year 2030. They are going to become as common as any heavy machinery we use today. So, as these machines step onto the factory floor and into our daily lives, how will your role evolve to work alongside them? Take some time to reflect on your own place in this rapidly approaching robotic economy. Thank you so much for joining this explainer, and keep learning.